Hey everyone, it's Mrs. Brimlow, and today I'd like to continue speaking with you about how to compare and order real numbers. So we're going to continue working with the notes we worked on either yesterday or previously. So it looks like this, topic 1, lesson 3. If you don't have a copy of the notes, you can just watch the video and get a copy later, or you should be following along. So yesterday we went over how do you approximate an irrational number when we have a non-perfect square root. And we need to know that as we get into comparing different numbers. So we're going to move down to example 2. So it says compare square root of 32 and 5.51326 dot dot dot, meaning it's going on forever. Then plot each number at its approximate location on the number line. So there's a few parts here. First, we need to compare them. Before we can even compare them, we have to figure out what is the square root of 32. We don't have a calculator, so that's why we're just going to estimate using what we know. So we know from our previous lesson, we need to find the square roots or perfect squares right around 32. So right before it would be 25, and right after it is 36. Square root of 25 is 5, square root of 36 is 6. So when I'm thinking of a number line and where this square root of 32 is going to fall, it's going to be a decimal somewhere between 5 and 6. I always like to put that benchmark in the middle when I'm trying to figure out where that's going to land, that decimal point. So to get from 25 to 32, their difference or distance is 7. And 32 to 36 is 4. So I can see that that square root is closer to 36, but not quite, meaning that it's bigger than 5 and close to 6, but not quite. So some approximations might be 5.6, 5.7, maybe even 5.8, okay? Any of those three would be acceptable. I believe, though, the closest is 5.7, so that's what we're going to use. So we estimated that the square root of 32 is about 5.7. Whenever you see an equal sign that looks like it has squiggly lines, it means an estimate or an approximation, okay? So now that we know what it is, we need to compare them. So when I compare 5.7 to 5.51326, excuse me, since this ends in the 10th place, that's where we're going to compare first. So when I compared 7 and 5, 7 is bigger. Therefore, the square root of 32, which we believe is about 5.7, is greater than 5.51326. Okay. And now we're going to draw a number line. Typically, they will be provided to you. However, if it's not, we're just going to keep it simple, okay? So by putting the arrows at the ends, that's showing the number line continues forever. Give me 1 second. And then I like to put 5.5 in the middle as a benchmark. So 5.51326 is a little bit bigger than that. And then we know square root of 32 is a little bit bigger than that, but still not quite 6. Okay. This would be appropriate. You have your points on there. You've got some reference points, 5, 5.5, and 6 to help you plot your points. Okay. All right, so now we're going to flip to the back and do our final example together. My face again. All right, so we're going to compare and order the following numbers. All right. So once again, decimal form is the easiest way because all numbers can be written as a decimal or estimated. So right away, we already have 9.8, 9.5 repeating, okay? So I still have pi squared, 9 1/2, and square root of 94. So 1/2 is a pretty common or what we call benchmark fraction. So you might be able to do that one right away. If not, you just have to do 1 divided by 2. And we'd get 9.5. So now we just need to figure out what's pi squared and what's the square root of 94. So I'm going to start with pi squared. So pi squared is about 3.14 times 3.14, okay? And this is rounded because pi goes on forever, okay? We haven't found an end to pi. It's irrational. So when I do that, I get roughly 9.9. I would not expect you to do this out by hand. I would allow you to use a calculator, okay? But having done this already, we can save ourselves some time. So we know that's about 9.9, okay? All right. So now we're going to estimate square root of 94. So the perfect squares around 94 are 81 and 100. So that means the square root of 94 is somewhere between 9 and 10. Okay. So from 81 to 94, I'd have to add 13. That's the distance, so not super close. 94 to 100 is 6, so those are a lot closer. So I could estimate this to be about 9.7, maybe even 9.8. I think for this one, though, we're going to go with 9.7. Right. All right. Now that I have all of these numbers in decimal form, I can go ahead and compare them or list them in a specific order. Now, you want to pay attention to what order they tell you. This just says to compare in order. It doesn't tell you which way to go, least to greatest, greatest to least. So when that happens, you assume it wants least to greatest. If it tells you, follow the directions. If it doesn't, assume least to greatest. Okay. So going with that, the least would be 9.5, and I'm going to use the original numbers. Okay. Then 9.5 repeating. I like to cross them out as I go so that way I make sure I got everything. Then we have square root of 94, then 9.8, and then pi squared. Okay. All right. So we compared the numbers to figure out what order they went in. We got them all in decimal form in order to order them from least to greatest. Okay. So if you have any questions, please reach out. Check out Canvas to see what your practice is, or if you're in class, see what the teacher has for you. And I will chat with you soon. Thanks.